This section explains the derivation strategy behind every interaction in the book, the raw material. Chapter 1 supplies, and the one defect that material cannot absorb on its own. Every interaction here is derived rather than postulated. Demand that an observed symmetry hold locally, independently at each point, and the fields carrying the force appear as the price. Chapter 1 only lays out the raw material that machine will consume, the left-handed doublets and right-handed singlets of Figure 1.1. It also lays out one defect. The machine cannot swallow as given. If an infinite range force and one spanning 10 to the minus 15 centimeters share a gauge origin, then the vacuum must hide that symmetry rather than the minus 15 centimeters share a gauge or than the Lagrangian. Quigg's treatment of elementarity is the sharper primitive. Point-like means unresolved at 10 to the minus 18th meters. An idealization index to the current microscope, and revisable when the resolution improves. This section explains why one scalar functional carries the whole theory. Write the Lagrangian, and stationarity of the action hands back the equations of motion. Require it to be invariant under a continuous transformation, and no other hands back a conserved current built from the very same derivatives. Dynamics and conservation are two readings of one object, which is why Quigg opens here. The chapter installs the machine, every later. Chapter runs backwards. The older practice guesses equations and checks their symmetries afterwards. Here you name a symmetry, and the invariant Lagrangian is nearly forced. Translation invariance already yields the stress-energy tensor and 4 momentum. A global isospin rotation on the nucleon doublet yields the isospin current. Chapter 3 makes that rotation local, and the free Lagrangian stops being invariant. This section explains how a redundancy in the description of electromagnetism gets promoted to a law. Maxwell's potentials carry more information than the fields do, many different. 4 potentials, a mu, give 1 electric field and 1 magnetic field. That surplus is ordinarily read as bookkeeping. Quigg's move is to stop reading the surplus as bookkeeping and read it as the generator of the interaction itself. The redundancy is what produces the force. Demand that a wave function's phase convention be choosable independently at every point in space, one convention in Paris and another in Batavia, and the ordinary derivative breaks the demand. Repairing it forces a compensating field into existence, a field carrying exactly the gauge transformation law of section 3.2. Demand that a 1B stays. The chapter exists for that inversion, symmetry as premise, dynamics as consequence. It is worked in the abelian case, so that the same construction can be rerun under a richer group. This section explains what happens when the gauge principle is applied to a symmetry whose group elements do not commute. The principle survives the jump unchanged in form. Demand that a naming freedom, proton versus neutron, be exercisable independently at each point of space-time, and the covariant derivative writes itself, d sub mu equals partial sub mu plus ig b sub mu, exactly as in electrodynamics. What changes is that the compensating field now carries the charge. It compensates. Because the group elements no longer commute, the field strength gains a commutator term, B sub nu, with B sub mu, the gauge, bosons therefore. Coupled to each other, and 3 boson and 4 boson vertices appear before any matter is present at all. Quigg's real thesis lands in the assessment. Consistency is cheap, correctness is not. Yang and Mills built their theory on isospin, and it is mathematically flawless and experimentally dead. massless quanta mean infinite range and the nuclear forces are short. This part explains how a symmetry can survive in the law while vanishing from what you observe. A law can hold a symmetry. Its ground state refuses. Chapter 4 left the gauge principle, predicting massless carriers for every force, and nature shows one photon. The move here is to keep the Lagrangian exactly symmetric and break the symmetry in the vacuum, where the lowest energy states are degenerate. Choosing one of them conceals the invariance without abolishing it. Quigg's anchor is the infinite ferromagnet, rotation invariant, dipole coupling, an arbitrary magnetization below the Curie point, and infinity as the reason that choice cannot be undone. The price is one massless Goldstone boson per broken generator, apparently a second embarrassment. That holds until the broken symmetry is local, where the Goldstone becomes the gauge boson's longitudinal polarization and mass appears. This section explains how the electroweak theory of leptons is constructed and what that construction costs. The recipe from chapters 3 through 5 gets run once on the simplest matter available. Pick a symmetry, the fermion's respect. Hide it the way nature did, read off the spectrum. Leptons are the test case because they carry no strong charge, so nothing contaminates the answer. What makes the chapter more than a worked example is that the construction is overdetermined. Fermi's effective coupling is fixed by low-energy data, yet it destroys unitarity at high energy, and the gauge group SU2L tensor U1Y is the repair that pays for itself, predicting neutral currents and a scalar nobody ordered. The closing move is the sharp one. The lepton sector alone is anomalous. Consistency demands quarks. Chapter 7 is a debt this chapter incurs. This section explains how the electroweak structure, already built for leptons, carries over to quarks, and what the one new ingredient does. Nothing new is gauged. The quark doublet copies the lepton construction exactly. The one addition is that the states the Yukawa terms diagonalize are not the states, the weak current pairs. That misalignment is a unitary rotation, and unitarity carries everything after it. The charged current sees the rotated basis, while the neutral current couples to the identity on a complete multiplet, and therefore cannot change flavor. The strange quark's absent partner was a completeness defect, and GIM read charm off the non-observation of K+, decaying to pi plus nu bar. Everything downstream, deeply inelastic scattering, W and Z production, the precision tests, the Higgs search measures that structure, and the closing hierarchy and vacuum energy sections measure where it stops holding. This section explains how Quigg builds the strong interaction as a repetition of an earlier construction with one sign flipped. The gauge recipe of Chapter 4's Yang-Mills construction, name the charge, gauge it, read off the force carriers, gets run again, now on color. Color is the choice because it is the one quantum number quarks carry and leptons do not. Nothing hides here. With no spontaneous breaking, the formulation is simpler than the electroweak theory that preceded it. What changes is the direction the coupling runs. Gluon self-interaction makes the effective charge shrink at short distance. That single reversal buys the chapter's entire license. Perturbation theory becomes legal exactly where quarks look free. So quasi-freedom inside the hadron and the absence of free quarks stop contradicting each other. This section explains why the Standard Model's product structure invites unification into a single, simple group. A direct product is a confession of ignorance. The group SU3 color times SU2 left times U1 hypercharge carries 3 separate couplings because it is 3 separate groups, and electric charge is quantized only by hand. Embed that product in a simple group and the arbitrary inputs become theorems. One coupling fixes the weak mixing angle, specifically sine squared theta W. The tracelessness of a generator forces the down quark charge to equal -1/3 of the electron charge. And quarks sharing a representation with leptons make the proton decay. This chapter is the book's inductive step. The gauge principle, until now fitted to what already exists, is turned forward and asked what must exist, with the unification scale near 10 to the 15th power. Giga-electron volts, read off where the running couplings meet. Quigg's own compression of the whole move. Why unify? Why not?